Hey there, let's cover linear functions. This is section 3.2. Okay, I'm going to read this just because hopefully it will make sense to some of you. A linear function is a function whose graph produces a line, period. Linear functions can always be written in, there's two forms given. In high school, you were told that the function of x is equal to mx plus b. But this class, unless you know that part like the back of your hand, I want you to try something different. In this class, I will strictly be using f of x is equal to b plus mx. Okay, they're equivalent. They're the same stinking thing. They're just flipping the mx and the b. B is always your initial or your starting value of this function. Okay. And M is your rate of change of the function. So it's how the function changes. If it does, if it doesn't change, it's a horizontal line and it's a constant. But if it does change, then your M is what's going to tell you how it changes. And we'll talk more about that here in just a second. All right, and then X is just what the input is. It's the independent number that's being plugged in to decide what the function is. All right, so let's keep going. For this reason alone, we're going to use this function. But remember, they are equivalent and can be written either way. So it's your choice how you want to do it. Just know that I will always be using the b plus mx in my video as well as in my lecture. Here, m is the constant rate of change of the function, also called the slope. The slope determines if the function is increasing, decreasing, and if there is no slope, no m in your function, then the rate of change is 0. So if you're given f of x is equal to 3 plus 2x, you'll notice this plus 2 is your slope. And notice it's positive, so it's increasing. Okay, if it's positive, it's increasing. If you have f of x is equal to 3 minus 2x, well, your slope or your rate of change is telling you that from the base 3, the starting value 3, your rate of change every time you plug in an x, that sucker's going down by 2 times that. So it's -2. If it's a negative slope, then it is a decreasing function. And an example of a horizontal line is when f of x is equal to 3. There's no rate of change, and there's no place to plug in an independent value, your x, because it doesn't matter. It's always, always, always 3. Okay. That's wrong. No, it's right. That's right. Okay. Sorry. I'm just trying to sit here and thinking through this. I'm like, how does that go? Y equals, yes, that's a horizontal line. That's perfect. So for this one, the vertical line, which we've already discussed, that is not a function. But what would this look like if it's, not a function? Well, first of all, it wouldn't start off with f of x because there is no f of x. It would just be x is equal to 6. Not a function at all. There's no f of or p of or any other function. So it's not a function. Okay. Marcus currently owns 200 songs in his iTunes collection. Every month he adds 15 new songs. Write a formula for the number of songs in his iTunes collection as a function of the number of months m. So remember how we're going to be using f of x is equal to b plus mx. But in this case, instead of the function f, they're using the function n. They just renamed it. It's nothing exciting. It's just to make sure you understand it's truly the number of songs. You could have made it s. It's whatever you feel comfortable with. But the number of songs based on the month, so that's what we're looking for, that's our independent or our input, is equal to what? Well, B is our starting value. How many he's starting off with? Starting value. He's starting off with 200 songs. I have to write this differently. N of M is equal to 200 songs. That's what he's starting off with. Okay, the next thing we need to look at is the sign. Is he increasing or is he decreasing? So you have to decide what sign based on what's happening in this situation. He is increasing, he adds. I know that I'm blocking a little bit of this. He's adding 15 new songs. How often? Every month. So he's adding, and the rate of change is positive 15. So he's adding 15 new songs every stinking month. Okay. So the next, that's our function. We've already done that first part. We needed to write a formula, which is also the function of the number of songs in his iTunes collection as a function of the number of months. Done. How many songs will he own in a year? Well, you can't just plug in one for year because this is based on months. Remember? So the input has to be in months. In regards to year, there's 12 months in a year, according to our useful conversion chart. So N of 12 is equal to what? Everywhere there's an M, we're going to plug in 12. So 200 plus 15. Okay, here's an M, so we're going to plug in 12. So 200, 15 times 12 is 180. 200 plus 180 is 380. So in 1 year, so in a year, I'm going to write this. Marcus will have 380 songs in a year. Now, in the previous discussions for this section, I have not made you write sentences other than the one about the police officers. From here on, we will be writing sentences for every stinking one because they're word problems at this point, and so we can discuss what's actually happening. So I would need to know from you what's happening. You need to be able to answer the question. How many songs will he own a year? He will own 380, and I need a timeline in a year. All right, this is a you try, so please pause the video and attempt this one on your own. Remember, before you do that, I'm going to give you a function of x. This is your basis for this, is equal to b plus mx. Okay, now pause and attempt this on your own. All right, you have just bought a new Sony 55-inch 3D television set for $2,300, $2,300. The TV's value decreases at a rate of $250 per year. Construct a linear function to represent the situation, clearly indicate what your variables represent. So if we change the variables, like, for example, if we say value, that's what I was thinking of, TV's value, that's what they used. So I'm going to say V is value. So that's my function. The value of the TV, I'll just use T. So T is the TV. Nope, it's not, we're doing it per year. We can't do that, can we? So I don't want to use T. Actually, I do want to use T. T is going to be time. The value of T, basically time, is equal to what? And the time is going to have to equal a year. Time is year. The initial value here. What's the initial value? It's $2,300. So the TV originally cost $2,300. You do not put dollar signs in a function. Okay, We don't use units until we write our sentence. So the value based on the year is equal to $2,300, $2,300. But what's happening now? Is it positive or negative? Is it increasing or decreasing? It's decreasing. So that means it's subtracting how much? 250. That's our rate of change. Subtracting 250 every year. Okay, because I said T is time in years. I indicated what my variables are representing. My function is V for the value of the television. The variable T is time for years. So now I can always find out, and that's all I needed to do for this question. But you know, hopefully you know by now, that's not all I would ask you. I would want you to tell me, well, how much is the TV worth in 3 years? So when 3 years comes about, what's the value of the TV in 3 years? And you would just plug in 3 everywhere there's a T. So 2,300 minus 250 times 3. One thing I do not want you to get confused by. In the previous example, we used months. We're not talking about months now. We're strictly talking about years. So the number I'm plugging in isn't going to be 36 to represent the months. It's going to be the number of years, 3. Okay. So what's the value in 3 years of this TV? That's 2,300 minus 750. What is that? 100 minus 750. I don't have a calculator with me. 5. I'm doing old school. So 8, 9, 10, 11, 12. 5. So the value of that TV in 3 years is $1,550. And so that's what you would say. If I were to ask you, what's the value of the TV in 3 years? I'll write that down. What is the value of the TV? Should have written this first. The TV in 3 years. And that's where the 3 came from. And you would write the value of the TV in 3 years, because you're giving that time element in 3 years, will be, now you need your units because we're writing a sentence to describe what's happening, will be $1,550. Okay. All right, I'm going to stop the video, come back with another one.